So this will be my competency for 4.1, I believe, which is the determination of a moment from a force and from a couple. So I have the force up top here and then the couple down here. I'll just go through both of them. Just hoping to make it a little easier for you. Just do it in one video, hopefully. So here we've got a snorkel boom, I think is what they called it. I don't know. But so we've got the boom, and I didn't draw it the best. The boom attached over here actually. So it stopped, and then we had a 2-foot distance that over from that his at the weight of the person in it, the worker, where his weight was acting. So that's why that is there. We had the angle of 50 degrees, and then the boom length is 25. I just included this to help see the triangle a little better. That helped me. So I actually just made it into a triangle, kind of like a free body diagram of the whole thing, the system. So we got our angle, and we want to find the moment around A. So to do that, I first had to find perpendicular distance, because the moment is the force times the perpendicular distance. So when it comes to a force like this, so to find the moment around A, I have to find this distance. To do that, I just did x equals 25 times the cosine of 50. This cosine will give me my adjacent, and that gave me 16.07 feet. Then to find the moment, so we were given his weight at 160 pounds, and that would be acting straight down because there's gravity and stuff, nothing else. So his weight's 160 pounds straight down, and it would be over 2 feet from the end of the boom. So we have a 16 plus the 2, which I have here. And then I have that 160, and that 160 is a negative force, but we don't really care, like if you were talking in the X and the Y, or I guess in the Y in this case, but that's not the reason it's negative. The reason it's negative is because it will create a negative moment. That's why this is negative down here, my answer. And that comes from a clockwise moment is a negative moment, a counterclockwise moment is a positive moment. So if I have my X here and I push down on it, that will go clockwise, so that means that's a negative moment. So that's how I like to think about it. I like to just kind of visualize, okay, if I had something perpendicular and I push down, that's how it's going to move. So that's how I thought of it. So that means it's a negative moment. So that's why that's that negative 2,891.2 pound-feet. So there's my moment from a force here. That would be the moment around A, so that means that this has to have a positive moment of at least that, or it would fall over. So hopefully it's somewhere close to 3,000, so we have a little leeway. But anyway, then this will be my moment from a couple, and I actually have 2 couples here, so I have to determine my resultant moment. I have this beam with a couple of anchor points on it. These are acting at 200 pounds this way and this way. And then same thing here, these are 125 pounds acting at 30 degrees. So these two 200-pound forces are my moments, and these 125s are my moments, and they're acting like that. Hopefully you can see that okay. The distance between these two is 1.5, and these two is 1.25. That is important because for a couple, you're not as worried about you still have the same moment equals force times distance, but you're not worried about the perpendicular distance anymore. For a couple, you're worried about the distance, which is the distance between them, which is why. So this 2 foot doesn't really matter. That's something that we won't worry about. We just worry about the distance between the two forces. So that's why we have this 1.5. So the moment of my 200-pound couple will be 200 pounds times 1.5 feet, because that's the distance between them. And this will be a positive moment because I have a force going this way and a force going this way. And the best way, I'd try to put a hand on each force, like you said, and just turn it like a wheel. And in that case, if it was a wheel, it would be going counterclockwise, which means it's positive. So I get my positive 300 pounds here. And same thing here, I have my 125 times the 1.25 feet, which is the distance between these two. Same thing, if I had a wheel like this, it would turn counterclockwise, which means it's positive. So my resultant moment will actually be pretty big. They're going to add to one another, so that would be something that you have to factor into when you're building that. So yeah, your resultant moment will be this 300 plus this 156.25 to give me 456.25 feet pounds foot-pounds for my resultant moment. So yeah, this is my moment from a force, and this is my moment from a couple. Hopefully it was a little easier that I did them together. So.